Hi. I'm Kevin from NCD Group. Today we're going to look at how the fourth tab works. The Rocketry Simulation tab. This tab includes background audio. Just like several others in this section. We'll begin by turning off the audio so we can go into detail in the explanation. In the first menu of this tab, we need to select one of the 4 available planets from which to launch. Below you'll see the characteristics of the selected planet. We also need to choose one of the 6 rockets available in the application. At the bottom, the main physical parameters of the rocket will be displayed. In the first page of the simulator, we assume it's a single-stage rocket. These parameters include total launch mass, burn time and rate, average exhaust velocity, and the delta V transferred to the rocket. You will see that you can select anything from legendary or classic rockets to state-of-the-art ones. In the next tab is the simulator itself. We must choose which graph or diagram we want to generate, either the altitude as a function of time and fuel burned, or the rocket's velocity at a given moment. We have buttons for run, stop, and clear to control the simulation, as well as a speed selector to adjust the simulation speed. There's also an option to jump to a key ignition moment. Regardless of whether you've selected altitude or velocity, both data points will be shown in real time, as well as the decreasing fuel quantity. The simulator also displays the value of gravity observed by the rocket based on altitude, and the formulas used for the calculations. There is also an option to compare 2 different types of rockets, with the possibility of configuring one of them as a custom rocket with the parameters you choose. In our example, we'll compare the Delta IV rocket against this custom configured rocket. We set the desired values for the custom rocket, choose the simulation speed, and compare how each performs in the velocity chart. Notice that the custom rocket, due to its high burn rate, empties the tank more quickly, which is why its speed begins to drop. If the rocket reaches escape velocity or if it enters freefall, which can happen especially on a planet like Jupiter, with its strong gravity field, a warning message will appear. Finally, there are 2 buttons. One to return to the previous menu and choose a new main rocket, and another labeled Advanced Calculations, which, when selected, takes us to the 2-stage rocket simulator. Initially, we see a tab with a theoretical explanation of how velocity increases during the final stage after the first stage is jettisoned. Then the simulator itself appears. In this second simulator, just like the first, we need to select a rocket, with its parameters displayed in real time at the bottom of the tab. We also select a second rocket, whose physical parameters will likewise be shown in real time at the moment of selection. We also need to choose the simulation speed, either 1x or 5x, and whether we want to focus on the altitude or velocity representation. In the graph, either altitude or velocity, 2 curves are plotted simultaneously, until the stage separation moment, which happens at around 66% of the total propellant burn time. Both the single-stage and 2-stage rockets are plotted together. This allows us to compare how well the 2-stage rocket performs versus the single-stage one in terms of altitude or velocity. At some point, the 2 curves will separate, and we'll be able to observe the red rocket, the single-stage rocket, and the black rocket, the 2-stage rocket, individually. Thank you for your attention, and happy space exploring.
If you like our content, hit like and subscribe to the channel.